Hello, Math 201. Welcome back. We're going to be continuing our, just grind and figuring out derivatives. And we're in section 3.9, derivatives of log and exponentials. So remember, if f of x is e to the x, then the inverse function of e to the x is ln of x. And remember what inverse is. Inverse does not mean 1 over f of x. 1 over f of x is the multiplicative inverse, but it's not the inverse function. The inverse function is the function that undoes the function. Ooh, what did I do here? I don't even know how I did that. So f inverse composed with f of x equals x, or f composed with f inverse of x equals x. That's what the inverse function is. So natural log and e to the x, those undo each other. It is the unique function such that if you plug in e to the x into the natural log or natural log into e, they both give you x. They cancel each other out. So here's y of x. The function e to the x looks like that. Natural log looks like that. Its domain are all positive numbers. Its range is -infinity to infinity. And so I won't belabor all the ideas, but the other important identity to remember is that if you have an exponential b to the x equal to y, you could take the natural log of both sides. So that's what I did here. And then the natural log of b to the x can come down. We take the natural log of both sides and then take e raised to both sides. And then e raised to the ln of b to the x can come down. And so then you have e to the x ln of b, and e to the ln of y is just equal to y because e and ln cancel out. And so e to the x ln of b is equal to b of x. That's this third property right here. And so we're going to use that a lot. Okay, so let's move on. The idea is that we know the derivative of e to the x is e to the x, but what about the derivative of natural log of x? Well, the way we can do that is by using the fact that if ln of x equals y, taking e to both sides gives us that e to the y is equal to x. And now we can do implicit differentiation. Implicit differentiation tells us that the derivative with respect to x of e to the y is just e to the y, but then times the derivative of the inside, which is dy dx. And the derivative of x is just 1. And so e to the y dy dx is equal to 1. So that means dy dx is equal to 1 over e to the y. But remember what e to the y was. E to the y is x. And so it's just 1 over x. Therefore, the derivative of ln of x is just 1 over x, as long as x is positive, right? You can only plug in positive x into natural log, but we can extend the domain pretty easy just by taking the absolute value of x. If you take the absolute value of x, that reflects the function across the y-axis, and it extends our domain. And now our derivative of the absolute value of x, natural log of absolute value of x, is still just 1 over x. But you can't have x equals 0 because natural log of absolute value of x is still not defined at 0. So the natural log of absolute value just allows us to extend the domain in case we need to plug in negative numbers. But in general, these are the things we need to reminder or keep track of. The derivative of natural log of x is 1 over x, and the derivative of natural log of absolute value of x is 1 over x. This one's true for positive x. This one's true for all x, as long as x is not 0. And then this is just a little chain rule idea, but the natural law, or if you take ln of absolute value of u of x, then it's 1 over that, which is 1 over u of x. And then you need to multiply by the derivative of u. And so you get this nice little rule. It's u prime of x over u of x. And this is true even if u of it doesn't have to be absolute value of u of x. You can just do u of x as long as u of x is positive. Because remember, you have to be able to plug in positive things into natural log. And so that's the idea. So let's do some examples. So let's find y prime. So dy dx will equal, so by the chain rule, it will be 1 over the inside function. So it's 1 over 4x, and then times the derivative of the inside function, which is 4. So times 4. And so this is just going to be 1 over x. So that's the derivative. And it actually turns out, and you'll see this in your homework, but that the derivative with respect to x of ln of kx, where k is any constant, is just 1 over x. And this is for all k greater than 0. So for any constant greater than 0, it turns out that you get the same kind of cancellation. It's still just 1 over x. Kind of interesting. For part B, copy, paste. Whoops. Let me paste the image. Paste the image. We need to use the product rule. And so by the product rule, we get that dy dx will be equal to take the derivative with respect to x of the first thing, which is 1 times ln of x, plus the regular of the first guy, x, times 1 over x. And so this just becomes ln of x plus 1. And so that's the derivative of that function. And then finally, let's just do this guy. And so because of the chain rule, the natural log of the absolute value of u of x is just u prime of x over u of x. And so we know what the derivative, so this will just become 1 over, so if y equals that, then that implies that dy dx, taking the derivative, is just 1 over secant of x, and then times the derivative of secant x, which is secant x tangent x. And then that cancels, and this just becomes tangent x. So it turns out that the derivative of natural log of absolute value of secant x is tangent x. And so that's the derivative. How about the derivative of b raised to the x? So where b is a constant. So this is called an exponential with base b, right? And b has to be generally a positive constant. Negative constants, you can't really do exponential functions with that. So we're going to use that identity from before, that b to the x is e raised to the ln bx. But then you can use the fact that this x can come down. And so it's e to the x times ln of b. So taking the derivative of this is really the same thing as taking the derivative of that thing. But this guy right here, by the chain rule, the constant just comes down. And then it's e to the ln of bx, but that's just b of x. And so it's really just ln of b times b of the x. And so this is the reminder of how you take e to a constant times x is just k times e to that constant. And so this is what the formula we get, that if you have a base that's bigger than 0 and it's not equal to 1, then the derivative of that exponential function is just the exponential function times the natural log of b. So for instance, this implies if f is 2 of x, then f prime of x is just 2 to the x times ln of 2. How about if we do a more complicated one? So how about this guy? 108 times 2 to the t over 12. Well, f prime of t, the 108 is just a constant, so that stays the same. And then it's times, and then it's 2 to the t over 12. That doesn't change. Times ln of 2, because that's the base. You have to multiply by the ln of the base. But then we need to multiply by the derivative of the inside function. And so times 1 over 12. And so that would be this right here. This is because from chain rule. So this is chain rule. Chain rule, right? This is just the derivative of 2 to the x. But then I need to multiply by the derivative of what's upstairs, which is that. That's the derivative of what's upstairs. And so if you calculate that, what would that become? That becomes 9 ln 2 times 2 to the t over 12. And so that's what the derivative of that function is. And so those are some examples of some exponential functions we can do. Now let's do some more interesting examples. So what about something like this? F of x equals x to the sine x. How do I do something like that? Well, remember, if you have x raised to a power, you can replace that with e and ln, because e and ln cancel each other, so it's the same thing. And then that brings the sine of x to the outside, and now it becomes this thing that we can take the derivative of. So to take the derivative, we can take the derivative of that, d dx of e to the sine x times natural log of x. But that's not too bad, because this right here, this inside function is just a product rule. And so the derivative is e to the sine x times ln of x, right? Because the derivative of e is just e. And then times the derivative times d dx of the inside, sine of x times ln of x. But to do that, that is just the product rule. So this right here, maybe I should do it in a different color. This, that's just the chain rule, right? That's the chain rule. I took the derivative of the outside function, which is just itself. The derivative of e is just e. And then I multiply by the derivative of the inside function, which is that. And so finishing this off, this is e to the sine x times ln of x, which this, remember, that is x to the sine of x, right? That was the original thing. And then times the product rule here. So this is where we have to do the product rule. The derivative of sine of x is cosine of x times ln of x. And then it will be minus, or sorry, plus sine of x times 1 over x. And so what does that finally give us? So using this substitution, we get x sine of x times cosine of x ln of x plus sine of x over x. And so that is the derivative of the function. And so it really is, it's just the function itself out here, and then the derivative of sine of x times ln of that. And so, yeah, this is a much more interesting example. Let's do one more example kind of like that. How about sine of x to the natural log of x? How would we do this? So again, we're going to replace sine of x to the ln of x. We're going to take the natural log of it first. So take the natural log of it and then raise it to the e. And then bring this guy, oops, bring the ln of x down. And so what does this become? This becomes e to the ln of x times ln of sine of x. Okay. And now we are ready to go. So let's take the derivative of that. So this is what sine of x to the natural log of x is. So we're going to take the derivative of this one. Copy, paste image. Whoops, not image. Let's just paste, paste. Let's take the derivative with respect to x of that guy. And by the chain rule, it's just e to the ln of x times ln of sine of x. And then times the derivative of the inside, d dx. The inside, this is a little bit more complicated now. It's still product rule, but it's product rule and a chain rule. And so there's a lot of pieces going on in it. So what is this equal to? This is e to the ln x times ln sine x times, and then doing the product rule, it's 1 over x times natural log of sine x plus natural log of x, because that's the regular the first, times the derivative of this, which is 1 over sine of x, because that's the derivative of that, the outside, but then I need to multiply by the derivative of sine, which is cosine of x, times cosine x. And honestly, if you're writing this on an exam, that's probably fine, but since I have time, I will simplify it. So let's simplify it. Let's remind ourselves what this is. That is what our original thing is, right? That is sine of x to the ln of x. That was the original function. And so let's replace that. So that's sine of x to the natural log of x. And then times, and then simplifying this, we get ln of sine of x all over x plus ln of x times cosine over sine is actually cotangent of x. And so we can leave it like that. That looks pretty good. So that's the derivative. It's pretty disgusting. And so in general, let me give you a general kind of way to tackle these. So the derivative d dx of a function f of x raised to a function g of x. How do we do that in general? It will be equal to the function f of x to the g of x, and then times the derivative d dx, the derivative of natural log g of x times f of x. Because using the fact that this, we can take the natural log and then bring the g of x down, and it's e to the g of x times, oh, actually, sorry, this should be ln of f of x times g of x. Ln of f of x times g of x. There we go. And then what is that equal to? That's going to be f of x to the g of x times, and then if you actually did this, it would be I guess the order doesn't matter. I have it the other way. I guess it should be g of x times ln of f of x, actually. It'll be g of x times ln of f of x by chain rule. And so what is that? That is going to be g prime of x times natural log of f of x plus f prime of x over f of x times g of x. And so in general, that formula will actually give you the derivative of f of x raised to the g of x, where f of x and g of x are just two functions. And so that might be helpful to you in the homework. Okay, let's do one last log trick. So one last log trick I want to talk about is when I have quotients of functions that are kind of complicated. I'm going to use the fact that natural log of a times b is natural log of a plus natural log of b, and the fact that natural log of two things being divided is natural log of a minus natural log of b. So that will help us take a derivative of something like that, because if I take the natural log of both sides, this becomes natural log of a quotient, and I can split it up into a bunch of different natural logs and take each derivative of each piece separately. So let me show you what I mean. So take ln of both sides. So what do I get? I get ln of f of x. I'm gonna call this y. I'm gonna call this y to make our lives easier. Take ln, so ln of y is equal to ln of x squared plus 4 times e to the x over x cubed minus 3. Now I can take the derivative with respect to x. D dx of both sides. D dx of both sides. D dx of both sides. Well, the derivative of this is not bad because of chain rule. It's just 1 over y times dy dx, which is what we want. Then to take the derivative of this thing, let's break it up. So it's d dx, and then let's use the log rules to break it up. It becomes ln of x squared plus 4 plus ln of e to the x, and then minus ln of x cubed minus 3. And this, by the way, is just x. That's just x. And so what does this become? This becomes 2x over x squared plus 4 plus 1 minus the derivative of the inside function, which is 3x squared, over the inside function, x cubed minus 3. And so then 1 over y dy dx equals that. And so the last step is just to multiply by y. And so dy dx equals 2x over x squared plus 4 plus 1. Maybe I should say that that is equal to x. That just equals x. That's where that came from, by the way. Minus 3x squared over x cubed minus 3. And then times y. But we don't want it in terms of y. We want to get in terms of x, but y is just this, right? And so let's just copy that, paste, and then copy, paste. So that is what dy dx will equal. It'll just equal this, which came from the natural log of the other thing, which was not hard to take the derivative of. And then you multiply it by the original function. And so that's the little log trick, and that will help you with the homework. All right, I will leave it there. Again, this week's homework is, or this section's homework is pretty difficult. And so again, if you have any specific questions, I can answer maybe over some videos. I'll do that, but this should hopefully get you going. All right, take care.